Hello everyone, welcome to Math Tired Club, where we make all those hard things in math very, very easy. I hope you're doing well. Don't forget to like, subscribe, and comment. Also turn on your notifications so that whenever I upload a new video, you will get notified immediately. I want to thank you for all the support and all those comments, nice comments that you leave on my videos. Thank you very, very much. I appreciate it, and it really gives me a lot of enthusiasm to make better videos every day. Okay, so let's go back to business and let's talk about graphing rational functions. But in my last and previous video, we had like the rational function in the form of y is equal to ax plus b over cx plus d, in which the degree of the numerator and denominator was the same and they were both 1. Today we're going to work on another example which the degree is going to differ, and I'm going to write the example down and I'm going to come back very quickly. So ta-da, I'm back with all the information that you need to know and have in order to be able to graph anything that looks like this. The very first step that you need to do is to actually factor these and try to simplify it if it can get simplified. So I'm going to have x minus 1, which can't get any simpler, and x squared minus 4 is one of the special cases. It's the difference of square, and I'm going to have x minus 2 and x plus 2. There is nothing from the top and from the bottom that can get simplified. Guys, have this in your mind. If there was anything that could get simplified from the top and from the bottom, that point is going to be a hole in our graph. I'm also going to upload a video on that too. So for example, imagine instead of x minus 1 on the top, we had, like, for example, x plus 2. The point negative 2, because you can actually cross these two out, the point x is equal to negative 2 is going to be a hole in our graph, and I will have like a video on it. Okay, so let's go back to what the question is about. The very first thing that we need to find are the vertical asymptotes. The vertical asymptotes are related to also the domain of the functions. Those are the things in the denominator that they will give us 0 in the denominator. Since the denominator can't be 0, we call those the vertical asymptotes. Okay, so whatever is in the denominator equals to 0, that's going to give me my vertical asymptotes, which one of them is going to be 2, and the other one, x plus 2, is equal to 0, which is going to be x is equal to negative 2. So I will have 2 vertical asymptotes here. Okay, so the next thing, I'm going to find everything and then I'm going to graph it, okay? So the next thing is the horizontal asymptotes, guys. There are some rules that I've written here for you to be able to graph, to find the horizontal asymptotes very easily. Of course, these are not rules that I just found them myself. They all have reasons. I will also make a video on those on these rules as well. So it says that if the top degree is greater than the bottom degree, so the first rule, look at the first rule. I'm going to repeat it again. If the top degree is greater than the bottom degree, we will not have any horizontal asymptotes, and we will going to have like a slant. Okay, I will also have a video on an example with a slant too. And if the top degree is equal to the bottom degree, which was my previous example, which I'm going to link in the description box below, the horizontal asymptote is going to be the division of the leading coefficients. And if the top degree is less than the bottom degree, which in this situation it is, because the degree of the top one is 1 and the degree of the bottom one is 2, the horizontal asymptote is going to be y is equal to 0. Okay, so y is equal to 0 is going to be my horizontal asymptote. And guys, just have this in mind that horizontal asymptotes are not like vertical asymptotes. They can get crossed. So you might think that, okay, if they can't get across, why are we finding them in the first place? Guys, they will tell us about the behavior of the graph, okay? And the behavior of the graph is very, very important for us, and it's going to help us to be able to graph the function, okay? So the next thing, I'm going to find the x-intercept. X-intercept is a point in which y is 0. So I'm going to have y is equal to 0. So then 0 is equal to x minus 1 over x squared minus 4. If you do crisscross, you're going to have x minus 1 is equal to 0, and therefore x is equal to 1. And that's going to be your x-intercept in which y is 0. So the point is going to be 1 and 0. I'm going to highlight it. So the next part is going to be the y-intercept in which x is 0. So if I substitute 0 for x here, I'm going to have y is equal to negative 1 over negative 4, which is going to be 1 over 4. So the point is going to be 0 and 1 over 4. Okay, so I'm going to highlight this one as well. I'm going to go and come back with my coordinate plane. So ta-da, I'm back with my coordinate plane. So the first thing is that I'm going to graph the vertical asymptote. So it's x is equal to 2. So x is equal to 2. I'm going to graph it dashed. And x is equal to negative 2. Again, I'm going to do it dashed. So then I'm going to have my horizontal asymptote, which is over here. Y is equal to 0. It's going to be on this line. Okay. And I have these 2 points, which is 1 and 0, 0 and 1 over 4. 1 and 0 here. 0 and 1 over 4 is going to be here. Okay, as I told you in the previous video that I will link in the description box below, I told you that in order to have the best results is for you, it's better to have your sign diagram, okay? So that you would know that how the graph is moving. If you don't want, you can just do it with substitution of different points over here and over here and over here and also over there, so that you would know how the graph is moving. But I myself recommend you to use the sign diagram because it's much easier, more professional, and it's going to be really, really great. I also have a video on that I will link in the description box below. I'm going to be back with the sign diagram. So ta-da, I'm back with the sign diagram. Over here, guys, so the root for this part of the equation is 1. Before this, it's going to be the opposite of whatever the sign of the leading coefficient is. So it's going to be negative, negative, positive, positive after that. And the roots are going to be here. The power is 2 in between the roots. We're going to have the opposite of the sign, and outside the roots we're going to have whatever the sign is. Negative times positive is going to be negative, positive, negative, and positive. Okay, so this is going to make everything 10 times easier. You're going to see it for yourself as well. So from negative infinity to negative 2, which is over here, because guys, see, this is negative 2. And this is like from negative infinity, okay? So from negative to infinity to negative 2, the graph is on the negative side, okay? So it will actually be locating here on the negative side. So guys, this is going to get so close to the asymptotes, the vertical ones, but it's not going to go through them. From negative 2 to negative 1, which is from here to here, see, from negative 2. So from negative 2 to negative 1 over here. From negative 2 to 1, sorry. From negative 2 to 1, which is this distance, the graph is going to be positive. So that's what I'm going to have. Okay, so as I said, from -2 to 1, the graph is on the positive side. So I'm going to have this. The graph is going to get so close to the asymptotes. Okay. And then from from 1 to 2, which is this small section over here, the graph is on the negative side. So I'm supposed to have like a turning point here. And I'm going to be down. And from 2 to positive infinity, the graph is on the positive side. So it's going to look something like this. Okay, so guys, here is the graph. Okay, I also recommend you to watch the previous video that is related to this as well. Guys, thank you so much for watching this video. Don't forget to like, subscribe, and comment. Turn on the notifications. Thank you so much for your support. I really appreciate it. I hope you all guys have a great day. Bye.